x coordinate and the y coordinate are the same. So y equals x is a very simple linear function. Oh, and remember, we could use either the variable y or the function notation f of x interchangeably, but we're going to use y in this video to keep it simple. Now that we've got that basic case covered, let's look at a slightly more complicated and much more versatile linear function.
Okay,
they
went over that pretty quick. So guys, remember, whether or not you're 5 for your coordinates, remember any of these points, if you click 5, 5, if you click 4, 4, if you click 3, 3, if you click 2, 2, they all need to do just 1, 1. So they will all simplify to your slope of 1 over 1, which is your proportional relationship, okay? That is your value right here, 1 over 1, okay? So make sure you guys are understanding that. No matter what point you have, right, 7 over 7 reduces to just 1 over 1, which is just 1, okay? Any fraction reduces, okay? So make sure you know that. The second thing is, if you guys don't remember from earlier this week, f of x, right, is just the output. So f of x, when we're talking about functions, is just another way of writing y. So y and f of x are the same thing. They use them interchangeably. So do not be confused with it. They're not putting f of x in this example. They're just going to be using y. But you can do that when you're using functions. F of x and y are going to mean the same thing. Okay?
So y equals x is a very simple linear function. Oh, and remember, we could use either the variable y or the function notation f of x interchangeably. But we're going to use y in this video to keep it simple.
Keep it simple.
Now that we've got that basic case covered, let's look at a slightly more complicated and much more versatile linear function. Y equals mx. This looks similar to the equation y equals x, but now the input variable x is being multiplied by a new variable called m. And by choosing different values for m, we can make as many different linear functions as we want. In fact, if we choose m equals 1, that would give us y equals 1x, which is just the same function as y equals x, because multiplying by 1 doesn't change the input value x. But what if we picked a different value for m, like m equals 2? That would give us the equation y equals 2x. And if we make a function table for that equation and then graph it on the coordinate plane, we get a line that looks like this. For every input value of x, the output y is doubled. Despite their differences, the lines y equals 2x and y equals 1x have...
So y equals 2x and y equals 1x, okay? You guys need to see, this is the slope that they're talking about. Notice what's happening when your slope is increasing, what's happening to the steepness of the line, okay? 1, the blue line, right, is not as steep as 2, the green line, right? Thinking about slope, and remember, if you wanted to graph these lines, right, remember these slopes or these values to m, whenever you have a whole number, you can just put that 2 over 1, and let's just say if this was the origin right here, I go up 1, I go up 2, and then over 1. Every time you continue that pattern, up 2 over 1, up 2 over 1, you will see that that is your slope of that green line. You can continue that pattern and graph that line to infinity and beyond. You need to know how to apply slope. You need to know how to apply m. That's what slope is referred to as a variable, okay? Pay attention to what happens with the slope when it increases or when it decreases, when it is less than 1, okay? You need to know this.
Have something in common. They both pass through the origin point of the coordinate plane, 0, 0. Because no matter what value we pick for m, if the value x is 0, the output y will also be 0, since anything multiplied by 0 is 0. Okay, what about if we let m equal 3 instead? That would give us this function table and this line as our graph. For every input value of x, the output y is tripled, but it still passes through 0, 0. Do you notice how each time...
So guys, again, if you guys didn't know, if you had a slope of 3, right, and you went up 1, 2, 3, just remember, you can turn any whole number. If this was your slope of 3, you go up 3. But then what, Mr. X? Well, you need to get your run, your horizontal change. right? So you need to change that into a rise over run. You can just put a fraction bar and a 1 over that, and you can turn that into a fraction, rise over run. And then you can continue that up 3 over 1, up 3, right, over 1, and that will continue your pattern. Remember, all slope is the shortest distance between 2 points on a line. That's what slope is. Up 3 over 1. The shortest distance between 2 points on a line. Okay? Now, any questions on this yet? You guys should know this. It should be review for the most part. But like I said, you guys said you didn't know about functions. They're a lot similar to linear equations. Linear functions and linear equations are very similar. Okay? So you know more than you think you know.
How each time we pick a bigger number for m, our line is getting steeper? Imagine that the line represents the side of a mountain or hill that you're climbing. Y equals 1x would be a steep climb, but y equals 2x is steeper. And y equals 3x is even steeper than that. In math, the steepness of these lines is called their slope. As we choose bigger and bigger values for m, the slope of the line increases. Did you say slopes? I love the slopes, man. Oh, you should have seen the massive air I just caught on the pipe.
Sorry.
That's pretty impressive. Caught on the pipe. You shred some more powder. That sounds pretty impressive. But getting back to mathematical slope,
Yes.
if we decided to let m equal 10, that would result in a really steep line, like this. And if m equals 100, the line slope is so steep that it almost looks vertical and is hard to tell apart from the y-axis of the coordinate plane. But we can never get a truly vertical line with this equation because there's no biggest number.
Okay, remember, you guys remember your 4 types of slope? We have positive slopes, right? That increase from 2 points going from left to right. So if you had 2 points going from left to right, all of these are positive slopes because they're going upward in a positive direction, right? They're all going upward in some way, right? They're all going in a positive upward direction from 2 points going from left to right. If you ever have a vertical line, right, it is going to be undefined, okay? Think about his example when he was talking about positive slope. It's like going up a mountain, right? The steeper your mountain gets, right, the harder it gets to climb. Eventually, if you ever got to a straight vertical line, there is no slope, right? It's undefined. It's like trying to climb up a straight wall. Like if you had a wall that just went straight up into outer space, you wouldn't be able to climb it because there is no slope, okay? It's just like a vertical line, right? There is no mountain, there is no slope to climb. And remember, when you have a horizontal line, right, that flat line is going to be 0. That's like a flat land, right? If you had 0 slope, that's just a straight horizontal line. So you have positive slope increasing from left to right, negative slope decreasing from left to right, undefined as a vertical line, and horizontal straight line is going to be 0 slope, okay? Again, these are things we've been covering since October, but like I said, if you said you don't know anything about linear functions, you guys know more than you guys are giving yourself credit for. So think about what we already know and start, right, thinking about how there's overlap with equations and functions, linear equations and linear functions, okay?
Oh, biggest number. The best we can do is keep picking bigger and bigger numbers for m. Say that the slope is approaching infinity as we do that. And that's fine because a vertical line doesn't qualify as a function anyway. So at the y-axis.
Okay, first question. The blank is represented by the variable m and represents the steepness of a line. What is it? What is m? Everybody needs to know this. I've been testing you on this for like 3 months now. Yes, absolutely. 25%. Excellent. Everybody needs to be participating. We're only taking 1 minute on this. If you guys don't have, right, your Nearpod working, you can put it inside of the chat and you guys will get 100%. Okay? So M is represented by what? Okay? Make sure you guys are following along. All we've been talking about is M. Rise over run. The steepness of a line. Right? What are we talking about? Exactly. 60%. Correct. Excellent. 65%. 30% no answer. You guys are missing out. Can we get higher than 65%? Yes, 70. Excellent. Okay, 75%. 25% no answer. Okay, solution. So what does M represent? Slope. Everybody needs to know this for 9th grade. If you go to 9th grade, your 9th grade teacher that you never learned what M equals, right? I'm gonna come find you. Okay? So make sure you guys know what M equals. It's the slope. Okay? I've been talking about this for 2 months. You guys need to know the slope and you need to know the y-intercept. Those are your 2 points, right? Or y-intercept to your 1 point and you find your second point by using the slope, okay? So you need to know what both of those are. So if you did not answer, make sure you submit that or you hit me in the chat to get credit.
So at the y-axis, we seem to have hit a limit. But what if we want to make lines that are less steep than y equals 1x? To do that, we're going to need to choose some values for m that are less than 1. Let's start by letting m equal 1/2, or 0.5 in decimal form. If we make a function table for y equals 1/2 x and graph the results, this is what our line would look like. Yep, that is less steep. Let's take it one step further and let m equal 1/4, or 0.25.
Okay, guys, if you guys didn't hear what he said, he's saying, how do I get a line that's less steep? Well, if your blue line is equal to 1, if you cut that in half, you get your orange line. So that is 1/2, right? The steepness of that blue line. And if you cut that orange line in half to get 1/4, right, you're going to see what that looks like. Notice the closer you get to 0, right, what happens to your line? It's starting to get to horizontal. And we just already covered that a straight horizontal line is equal to 0, okay? Let's pay attention.
The function table and graph for that equation would look like this. That slope is even less. As we choose smaller values for m, our slope is decreasing. And if we keep on picking smaller and smaller values for m, like m equals 1/10 or m equals 1/100, you can see that our line is looking more and more like a completely flat line, and it's getting harder to tell the difference between it and the horizontal x-axis. Now you might be wondering, can we make a line that's perfectly horizontal? Yes. Unlike the case when our line was getting steeper and steeper, but we couldn't ever get it to be a perfectly vertical line, we can make our line perfectly horizontal simply by choosing m equals 0. Doing that gives us the function y equals 0, which is just about the most boring function you can think of. But it's helpful to see because it shows us that a perfectly horizontal line has no steepness, or a slope of 0. It would be just like walking a...
Okay, you need to know this, right? A horizontal line that is just straight, horizontal, has a slope of 0. So 0 slope. Whenever you guys see a straight line that is horizontal, it has 0 slope, okay? Everybody needs to know that. In addition to positive slope, negative slope, and undefined vertical line, or vertical slope. It's not a slope, vertical line.
It's like walking along perfectly flat ground. Okay, so in our linear function, y equals mx, the variable m is the slope of the function. If we start with m equals 0, and then gradually increase the value of m, our line slope gets steeper and steeper. It approaches a vertical line, but it never quite gets there because we can't ever really get to infinity. There's always a number that's just a little bit bigger. As you can see, the function y equals mx can make a lot of different lines. But wait, there's more. Don't forget about negative numbers. What would happen if instead of picking m equals 1, we pick m equals -1? If we make a function table and graph in that case, we end up with a line that splits quadrants 2 and 4 exactly in half. It has a slope that's similar in magnitude to y equals 1x, but as you move from left to right, it's going downhill instead of uphill. The slope is -1. Basically, all of the negative values of m give us lines that are just mirror images of the lines we get from positive values of m. This is m equals 1. This is m equals -1. This is m equals 2. This is m equals negative 2. This is m equals 1/2. This is m equals negative 1/2. See the pattern? All of these possible lines have a positive slope, and all of these possible lines have a negative slope. And when we consider all possible values of m, you can see that the equation y equals mx can describe any linear function that passes through the origin of the graph at 0, 0.
What's the difference between a positive and a negative slope? What is the difference between a positive and a negative slope? That's the next question that we're all working on. You guys should know the difference between a positive and a negative slope. Let's just say I have this cool little mountain. I got a mountain, guys. All right. Now, from 2 points going from left to right, which are increasing from left to right in an upward direction, that's positive. Increasing in an upward positive direction. Remember, if we're going up on our y-axis, we're going in a positive direction, positive slope. Now, from 2 points going from left to right, if they are decreasing in a negative downward direction, right? They're going in a negative downward direction from 2 points left to right. That is a negative slope. You all need to know this for next year. You need to know the difference between a positive and negative slope. We've been going over this since October, November. Okay, that's when we first started talking about this. Positive slope increasing from left to right, 2 points from left to right in a positive direction. Negative slope is decreasing from 2 points going from left to right. Talking about this point. Notice if I'm going from left to right, I can see that this just significantly went down. It decreased because it's a negative slope. Okay? Same thing. If I look at the other side, if I'm looking at my 2 points here, I can see this point going from left to right. Right? My next point is up here. That's increasing as a positive, right? In a positive upward direction. Okay? So positive slope increasing, like you're going up a hill. Negative slope, it's like you're decreasing or coming down a hill. Okay? You all need to know that. If you did not put your response in, you need to do that. So 35% of you, no answer, that's going to get you a 0. Okay? If you don't know, click you don't know. But if you don't know since October, that just means you guys have not been doing your work. Please come see me during one of the academic support times, okay? And I will help you.
But what if we don't want to be limited to lines that pass through the origin of the coordinate plane? No problem. All we have to do is add something to this very simple linear equation. And I mean literally add something. We're just going to add a variable called b to the end of our equation, which will give us y equals mx plus b. To see what effect this new added variable has, let's set our m value back to 1 and keep it there while we just try out different values for b. And we'll also leave the graph of y equals 1x on the coordinate plane as a reference to see how it compares to our new lines that have b values. Let's keep things simple and start with b equals 1. That gives us the equation y equals 1x plus 1. And if we make a function table and graph it, this is the line we get.
Okay, remember input-output values. Can you input a value to get an output? If you can input that value, yes, you can output that value and you can graph it. So when we have a value of 1 for your y-intercept, you can see how that, right, y-intercept value increases by 1, okay? Again, using your coordinates, right, you can graph these points, okay? That's what this table is for, graphing your, right, function.
Notice that it's parallel to the reference line. And that makes sense because in both equations, y equals 1x and y equals 1x plus 1,
same slope.
M equals 1. So the slope is the same for both lines.
So remember, when the slope is the same and the value for b or the y-intercept is different, then you have two parallel lines. Remember this from systems of equations? Whenever you have two parallel lines that don't intersect, there will never be any solutions. So if you had these two equations, you would say no solutions because they're parallel and they never intersect. okay? And we get that when we have the same slope. That's the same slope for green and blue, but different y-intercepts. Notice how the green line is +1 off of the origin. It's just up 1 unit on the y-axis. That's it. That's the difference.
What's different is that the value we chose for B, +1, shifted the entire line up on the coordinate plane by 1 unit. The line doesn't pass through 0 on the y-axis. It passes through +1 instead. Okay, what will happen if we choose B equals +2? That gives us the equation y equals 1x plus 2. And its graph looks like this. It's been shifted up 2 units and now passes through the y-axis at +2. And if we pick B equals 3, it would shift the line to intercept the y-axis at y equals 3. The bigger the value for B, the farther the line is shifted up.
Okay, so remember, the first thing that we do whenever we graph our equations in slope-intercept form is we graph our y-intercepts, okay? That is going to give us the point, right, on the y-axis. After we do that, it's as simple as just doing your rise over run. So you can do your rise over run, up 1 over 1, up 1 over 1, up 1 over 1, and you can see the shortest distance between 2 points on a graph line is the slope. So they all have the same slope, up 1 over 1, up 1 over 1, up 1 over 1, no matter which one, green, blue, red, or purple, right? They all have the same slope, 1 over 1, but they have different y-intercepts. Remember, your value to B is your y-intercept. Your value to B is your y-intercept, okay?
But what goes up must come down. Can you think of a way to do that? To get the reference line to shift down instead? Yep, let's try using negative numbers for B. Remember, adding a negative is the same as subtracting. If we choose B equals -1, we get y equals 1x plus -1, which is the same as y equals 1x minus 1. Sure enough, that shifts the line down so it crosses the y-axis at -1. And if we choose b equals -2, it would shift the line down so that it crosses the y-axis at -2. So do you see what the variable b does? It determines exactly where the line will intercept the y-axis. It does that because whenever x equals 0, which happens only at the y-axis, the mx term will be 0 and we'll be left with only b. So when x equals 0, y will just equal b. Because of that, b is called the y-intercept. And as we saw earlier, m is called the slope of the line. And that's why the equation y equals mx plus b is called the slope-intercept form of the line.
Okay, remember, slope-intercept, all that's referring to is 2 points. If you can graph 1 point, if you can graph 2 points, you can connect dots, right? And you can create a line. That's all we're doing here. We're graphing 1 point, and from that point, the y-intercept, we are using our slope to find our second point, okay? So if you understand what the slope is, m, and what the y-intercept is, d, you can graph those 2 points and graph a line using this form, okay? That is what we're doing, or what we've been doing. If you guys still don't know this, you guys gotta come to academic support times, okay?
Of a line. The two parameters, m and b, determine the line's slope and its y-intercept.
Yes.
And with this simple linear equation, you can describe any possible linear function on the coordinate plane.
Okay, what is represented by the variable b? It represents the point where the line crosses the y-axis. Who's paying attention? Who's playing video games or watching Netflix? I can see. Not really, but I can see if you guys are paying attention by your participation and by your scores. If you are getting this wrong, again, 3 months into doing this, then that's going to be a problem. So make sure you guys understand what B represents, okay? And make sure you guys know what M represents. We already talked about M. M was the slope, okay? M was the slope. So what is B? Nice, 75%. So 25% did not answer. If you guys put it in the chat, you guys will get full credit for that. 100% if you do that. Okay, so what is the answer? B is equal to The y-intercept, exactly. If you can plot your y-intercept, then you can do your rise over run from that point, and now you have your second point. You just grabbed your line. You guys are brilliant. Okay? Let's keep it moving.
But you might be wondering if that's really true. I mean, don't we also need to be able to shift the line side to side? Nope, and here's why. Let's say you want to make this line that appears to be shifted to the left of the y-axis. Well, if we zoom out just a little bit, you'll see that we could get the exact same line by shifting our parallel reference line up on the y-axis instead. This works because the lines are diagonal and they continue on forever in either direction. So moving them up and down is equivalent to moving them left and right. You can graph any 2D linear function with just two parameters. The multiplied variable m to rotate the line, and the added variable b to shift the line.
Y-intercept.
And that's why the equation y equals mx plus b is so important.
Yes.
It's really all you need. But of course, there's always ways to make things more complicated, and you'll probably encounter linear equations in a lot of different forms. But as long as the equations are truly linear functions, you can simplify them into this y.
That's what we're talking about. When you see equations that are, or linear functions, right, that are in this form, you can isolate the variable y to solve, right, or to graph.
Y equals mx plus b format. Okay, but how do you tell if you have a linear function if it's in a different form? Well, to be a linear function, equations can only contain first-order variables. That means that the x and y terms in the equation can't be squared or cubed or raised to any powers other than 1. So these are all examples of linear equations, but these are not. And to see how you can rearrange any linear equation,
So notice, linear, there's no exponents, right? Not linear, you're dealing with exponents, it's gonna get crazy. We're not talking about curved lines right now, we're sticking to simple lines, okay? You guys need to know this basic stuff so that you guys can start getting into the, you know, the harder stuff in Algebra 1 and Algebra 2 next year. So make sure you guys are understanding y equals mx plus b, okay? This is the foundational stuff, guys.
equation into the form y equals mx plus b. Let's try to do that to the first equation on this list. X minus 4 equals 2 times the quantity y minus 3. We're going to use what we learned in previous videos about combining like terms and rearranging equations to get this into the y equals mx plus b form so we can easily tell what the slope and y-intercept will be. Let's see. We want to get y all by itself, so first we divide both sides by 2. On the right side, the 2's cancel, and on the left side, we have to distribute the division so we get x over 2 minus 4 over 2, which is the same as 1/2 x minus 2. The next step to get y by itself is to add 3 to both sides. On the right, the minus 3 and the plus 3 cancel, and on the left, we have minus 2 plus 3, which is positive 1. So the equation becomes 1/2 x plus 1 equals y, or y equals 1/2 x plus 1. Now it's in y equals mx plus b form, so we know that the slope is 1/2 and the y-intercept is positive 1. All right, so
Okay, so we're gonna stop that right there. So a lot of stuff was review, a lot of stuff, right, overlapped with things you already know. So I hope, right, that some of you guys are starting to see, right, the relationship between linear equations and linear functions and how they have similar characteristics and how we can solve both, right, they're using the same, right, formula. If you guys go into your classwork today, you guys are going to see the IXL is just evaluating linear functions. All you are doing is taking your functions, v is equal to k plus 8, and you're given a value, an input value. Whenever you're given an input value, you can plug that into your function to get your output. So my input is k is equal to 5. So what is 5? K is 5. So 5 plus 8. 5 plus 8 is going to give me my output, which is 13. 5 plus 8 is 13. And all you're doing is plugging in your values, right? When given your input values, h is equal to 8. So in your function, you look for whatever that variable is, and you plug in that value, 8. 8 plus 7. If you know what 8 plus 7 is, right? You could do these type of problems, right, individually, but if you guys need extra help, again, you guys can come see me during academic support times during third period, okay? So I will help you guys complete these things. You guys need these skills here, okay? So make sure you guys are completing your stuff, right? That way you guys are going to be right where you need to be for next year, okay? Don't forget, whenever you have a coefficient next to a variable, that is multiplication. So if I have q is equal to 9, 5 times 9, right? All you do is put that in. You guys know how to multiply, you guys know how to divide. Now we're plugging in and we're evaluating input and output. We got the puzzle pieces, guys. You guys are making that puzzle, okay? If you need help, just come to academic support times or send me an email and I got you. That's all the time we have. Go in peace. Get your breaks. Take care. Bye, guys. Bye, everybody. Bye, Tyler. Bye, Tyler.
Bye, Mr. X.
Bye-bye. Bye, guys. Hope you guys have a good day. That's all the time we have. Go take your breaks. Get some fresh air. Bye, everybody. Bye, everybody. Bye, Kayla.
You getting breaks then?
I don't have a break. I live here. We have a break for 10 minutes, so the next class starts at 1:50, okay? All right. Nice to see you guys. Bye, JJ. Bye, everybody. Bye, JT. Bye, Marie.